Okay, hi everyone. Today we are going to be looking at partial fraction. That's one of your topics in Maths 101. Now, partial fraction involves the breakdown of a complex fraction into simpler fractions. So you take a complex fraction and break them into simpler fractions. Now, there are actually 4 cases that we can achieve that. So in this particular study, we are going to be looking at just 2 of the cases. Case 1, the denominator must be factorizable and distinct. Distinct means they must be different. Just like this example here, we are asked to resolve 2x plus 3 all over x minus 1x plus 3. The denominator is factorizable. That's the reason why we have 2 factors here. And distinct mean that they are different. This is x minus 1 and this is x plus 3. Okay, so how do we resolve this into partial fraction? Now, we can say we have 2x plus 3 all over x minus 1 and x plus 3. According to partial fraction, we can break this down into a over x minus 1, then plus b over x plus 3. Okay? The next step here is to multiply through by x minus 1, x plus 3. Multiply through by x minus 1, x plus 3. Okay, so that becomes, at that point, multiplying this by x minus 1, x plus 3. Okay, let me just do it this way. All over x minus 1, x plus 3 multiplied by x minus 1, x plus 3, now equal to a over x minus 1, now multiplied by x minus 1, x plus 3, then plus b over x plus b, x plus 3, multiplied by x minus 1, x plus 3. Okay, so at this point here, this would cancel this and this would cancel this. We are left with 2x plus 3 equal to, here x minus 1 cancels x minus 1. We have a into x plus 3, then plus b, x plus 3 here cancels x plus 3. We have b into x minus 1. At this point, we can take each of these factors here, x minus 3, x plus 1. We need to find a and b. Okay, so we can start by saying let x plus 3, which is one of the factors here, let x plus 3 be equal to 0. That means x equal to minus 3. We can substitute it down here. So it means we have 2 into 3 plus 3 equal to a into 3 plus 3. Sorry, this is minus 3. Your x is minus 3. So a into minus 3 plus 3. Then plus b into minus 3 minus 1. Okay, so that would be minus 6 plus 3 is equal to minus 3 plus 3 is 0, makes the whole of this 0. So we are left with b into minus 4. Minus 6 plus 3 here is minus 3 equal to minus 4b. So we can say b is equal to 3 over 4. Okay, now for a, we can pick the second factor here, which is x minus 1. We can say let x minus 1 be equal to 0. Then x will be equal to 1. So if we substitute x equal to 1 for x in this very equation, we are going to get 2 into 1 plus 3 equal to a into 1 plus 3 plus b into 1 minus 1. Now 1 minus 1 is 0, makes the whole of this 0. Here 2 times 1 is 2 plus 3, which is 5, equal to 1 plus 3 is 4, equal to 4a. So from here we can see that a is equal to 5 over 4. So we found the value for a and the value for b. We can go back and substitute. So that means my 2x plus 3 all over that means 2x plus 3 all over x minus 1 x plus 3 is equal to a over, my a now is 5 over 4 all over x minus 1 plus b is 3 over 4 all over x plus 3. Good, which we can also write as 5 all over 4 into x minus 1 plus 3 all over 4 into x plus 3. Okay, so let's look at another example here. Here we ask to resolve 5x plus 1 all over x squared minus 3x plus 2 into partial fraction. The first thing I would do is to resolve this, to factorize this. So you have 5x plus 1 all over x squared, minus 3x plus 2 is the same thing as 5x plus 1 all over, resolving this is a quadratic equation. Resolving this, I'm going to get x minus 1 x minus 2. Factorizing this is going to give me this. Okay, that's quadratic equation. Now we can continue by saying that 5x plus 1 all over x minus 1 x plus 2 is equal to a over x minus 1, this is minus 2, plus b all over x minus 2. Now the next is to multiply through by x minus 1 x minus 2, which is the LCM of the denominator. At that point we'll have that 5x plus 1 equal to, multiplying this by this, x minus 1 cancels x minus 1, so we'll be left with a into x minus 2 plus b into x minus 2 here would cancel x minus 2 to be left with x minus 1. Okay, so I can pick one of these factors, x minus 2, x minus 1. Let's say let x minus 2 be equal to 0. So that means that x is equal to 2. If I substitute that here, we're going to get 5 into 2 plus 1 is equal to a into 2 minus 2 plus b into 2 minus 1. Okay, and 2 minus 2 here is 0, makes the whole of this 0. 5 times 2, 10 plus 1, which is 11, equal to, this is b times 1. So from here we can see that b is equal to 11. Now if we pick the second factor, which is x minus 1, we can say let x minus 1 be equal to 0. So meaning that x is equal to 1. That means when minus 1 crosses over, it becomes 1. Then substitute the value of x here into this. So we are going to have 5 into 1 plus 1 equal to a into 1 minus 2 plus b into 1 minus 1. So 1 minus 1 here is 0, cancels the whole of b. Then here we have 5 times 1, which is 5, plus 1, which is 6. So 6 is equal to 1 minus 2 is minus a. Okay, minus 1 times a, which is minus a. So here we can say that a is equal to minus 6. Good. Now we can substitute the value of a and b into this particular expression. So we can now say that 5x plus 1 all over x minus 1 x minus 2, which we say is equal to a all over x minus 1 plus b all over x minus 2 can now be written as, what is our value for a? You see here your a is minus 6. It's going to be minus 6 over x minus 1 plus b. What is our value for b? Our value for b here is 11. 11 all over x minus 2. So that becomes the answer. That is the answer for that question. Okay, so this is case 2. The condition is that the denominator must be factorizable and equal. Okay. Now for case 1, the denominator must be distinct, factorizable and distinct. Distinct means to be different, but here they must be equal. So just like here we have, look at this example, 3x plus 5 over x plus 1 squared. Now this can also be written as x plus 1, okay, to show you that the denominators are factorizable. Okay, so we look at the solution. We have 3x plus 1 over x plus 1 squared. How do you treat a case like this? It's the same thing as x plus 1, a over x plus 1 plus b over x plus 1 squared. Now, assuming this was x plus 1 cube, I would have continued plus c over x plus 1 cube. Okay, so if we multiply through now, the next stage is to multiply through by x plus 1 squared. If we multiply through by x plus 1 squared, this would be 3x plus 5 equal to, multiply this by this, x plus 1 will cancel one of these. I'll be left with a into x plus 1, then plus b. Okay, at this point I can pick, we have only one factor here, which is x plus 1, so we can say let x plus 1 be equal to 0. That means x is equal to minus 1. And we substitute x equal to minus 1 for x in this particular equation. So we're going to get 3 into minus 1 plus 5. Now equal to a into minus 1 plus 1, then plus b. And of course, like we know, minus 1 plus 1 is 0, so cancels the whole of this. And 3 times minus 1 is minus 3 plus 5. Now equal to, on the right hand side here, we just have b. So we can see that b, our value b is equal to 2. B equal to 2. Now to find a, if you notice, we have just one factor, which is x plus 1, just that it is repeated twice. but there is no other factor we can use to find a. So in this case, what do we do? At this point, you can assume any value for x. You can assume any value for x. I prefer using x to be equal to 0. And substitute that value for x into our equation. So this is now going to be 3 into 0 plus 5 is equal to a into 0 plus 1, then plus b. Okay, 3 times 0 is 0 plus 5 gives us 5, equal to a plus b. Now this is good. Our b already, we found b to be 2, so we can substitute the value for b. We have 5 equal to a plus 2. So we can say a is equal to 5 minus 2, which is equal to 3. So now we have our value for a, and we have our value for p. Our a is 3, our b is 2. So we can substitute into our original equation. Now that means that 3x plus 5 all over x plus 1 squared can now be written as being equal to, your a is 3 all over x plus 1, then plus b is 2 all over x plus 1 squared.